Okie dokie, welcome back. Today we are going to talk a little bit more about our chapter on data sets and distributions, and we're going to focus on some new vocabulary words. Center, spread, outlier, shape, and we describe shape when we talk about the skew of the data. If you have your math glossary that you started, I believe, last week, go ahead and pull that up or use a piece of paper and take some notes and add to your glossary when this is all done. All right, we're going to go ahead and take a look at this first data plot. We have 25 sixth grade students who are asked to estimate how many hours a week they spend talking on the phone. This dot plot represents their reported number of hours of phone usage per week. Now, I don't think this includes texting or Snapchatting or Instagramming or TikTok or any of those other things that you guys do on the phone, really just talking on the phone. We can see that we have a lot of students here, about 10 of them, that don't talk on the phone during the week at all, or maybe they don't have a phone. Then we have about 7 kids here talking about an hour. We have 5 kids talking for 2 hours and 3 kids talking for 3 hours. So I want to kind of throw a question out to you. How many hours would you say that these students typically spend talking on the phone? And we're thinking about that word typically. So I would say that these students typically spend about 1 hour on the phone per week. And we can see that by if there's about 10 kids here, and then over here in 2 and 3 hours, we have 8 kids. So that means somewhere here around 1 hour is the center of that data. And so that's what we're talking about. Typically refers to the center of the data. All right. We have another dot plot. This one shows the number of hours per week that these 25 students reported spending on homework. So we have a big range here. We start out at 0 hours per week, and I would say that this is probably before we started online learning. Hopefully nobody's in that 0 mark. And then it goes all the way up to, we have a student doing 9 hours. So how many hours per week do they typically spend on homework? Well, the center of the data is going to be right around here, right around 3 hours per week. So over here on this side, we have 1, 5, 4. So that's about 10 students over there. And then over on this side, we've got 3, 6, 7, 8, and then we've got 9, 10 in here, 11, 12, 11, 12 here. So this number, this little dot right here is about the center of our data. So the center would be around 3 hours per week. So this is the point where you may want to pause the video and go ahead and take some notes or add this definition to your glossary. The center of a set of numerical data is a value in the middle of the distribution. It represents a typical value for the data set. And we have an example there for you as well. Okay, I'm going to pull those 2 dot plots back up, and we're going to take a look here at the homework per week and the hours of on the phone per week. And we're now going to talk about another term, which is called spread. So when we look at the dots on this dot plot right here, we can see that the values are pretty spread out. They go all the way from 0 all the way up to 9. But when we're looking at the hours on the phone per week, we only have a spread of 0, 1, 2, and 3. So the data in this data plot is much closer together, and it's a pretty small spread. But when we're looking at hours per week, that's really spread out, actually. We have a lot of variability in our data there. So the students are more alike in their phone usage than they are in their time spent on homework. The spread of the data is much larger on the homework time dot plot, which means that there's much more variability, which I already said, in the time they spend doing homework than the time that they spend on the phone. So that brings us to our next definition. Again, you may want to pause the video, write down spread. The spread of a set of numerical data tells how far apart the values are. All right, and there's an example for you as well. All right, so our next thing that we're going to actually talk about is something called normal distribution. We're now going to talk about the shape of the data. And before we can do that, we need to look at what is normal distribution. How is our data normally distributed? So it can be spread out more on the left in this yellow bar graph. It could be spread out more to the right in this bar graph, or it could be all jumbled up, right? But when we're talking about normal distribution, that's when we have this, what's known as the bell curve, okay? The normal distribution. So when we're looking at this histogram, we can see that the data is distributed both sides pretty evenly. And we call this a bell curve because it kind of looks like a bell. So when we're talking about normal distribution, we want to say that it has symmetry, that about half the data is on this side and half the data is on the other side. That would typically mean that our mean, median, and mode would all be the same right in the middle of the data, right in the center. So this is what normal distribution looks like. All right, now we're going to go and take a look at what happens when our data is not perfectly shaped like this. We're going to take a look at outliers. And I'm getting this off the Math is Fun website. That's a great place to look these things up and get a little more information on them. All right, our next vocab word is going to be outliers. And an outlier is something that lies outside of the other values. So you can see on this dot plot or this number line, this outlier, this data plot's way over here. Everything else is kind of all together, but this one's pulling all of it over to the right, okay? And the example they give is that the coach has been working on the long jump with his team, and this is their data that they've got. And when they put this data into this number line, this dot plot, we can see that Sam, he has not improved, right? So his performance went down. Everybody else went up, but Sam went down. So his is that outlier. And when we have an outlier, it's going to pull your mean, your average, down, right? It's going to pull that down. So sometimes we like to take that outlier out of our data so that we can get a better sense of where the average is. And so if we take the outlier out of our calculations, then our mean is up here in the middle of all this data, and that kind of makes a little bit more sense. So that outlier is this piece of data that is separated from all of the others. So we can come back, and I have created another vocab card for you. So go ahead and pause the video again. An outlier is a value in the data set that is much greater or much less than most of the other data. They are values that lie outside the other values. Okay, we're going to take a look at our last word, which is skew or skewed data. So when we're talking about the shape of data, we discussed already what is normal, the normal distribution. We also have what is sometimes known as negative skew. That means the data is really over here on the left side. So we can see that this is the center of the highest point there, the mode of the data, but it's kind of pulled over to this side, the left side. If the data is pulled over here to the right side, it's a positive skew. All right. So when we're talking about the skew, we're talking about this sort of tail, right? So we've got the mean of the data right here. And the tail is kind of over here, skewed to the left. So that's what we might say when it's skewed to the left. It has a negative skew, and there is more data on this side of the mean. Again, that normal distribution has symmetry, and 50% of the data is on one side of the mean, 50% of the data is on the other side. So that's that normal distribution. It's not skewed, it's perfectly symmetrical, and the mean is exactly up here at the peak. And then we can look at this other one, the positive skew. That's where we have the long tail pulling the data over here to our right side. It's called a positive skew or skewed to the right. So I'm going to go back to my slide, and I've got one more definition for you to write into your glossary. Skewed distribution, when data is pulled to the left or the right. It's not a normal distribution, and it does not have symmetry. All right, so make sure that you get all 4 of these words into your glossary. And then the rest of the week, we're going to be spending doing some activities where you're going to see these words. If you need to, you can go back and either reference this video or reference your notes. All right, thanks, guys.